Right, good day once again, dear students. Now, I would like us to look at the two group disconnections. So, like for all this time, like we've been dealing with one group, what called disconnections. Now, I would like us to look at the what? The two group what? Disconnections. Here's an example, for example. Here, if I start if I look at the 1,3-dioxygenated what? Skeletons, right? 1,3-dioxygenated skeletons. Then how do we, disconnect this type of compounds, right? Remember, whenever you have your target molecule, right? So what is it that you do? You break it down, right? Right? Now, like, how do you do that? You don't do it haphazardly, right? It has to be a logical what? Process. That's very important. Then also, right? And then when you break this down, you break them down to your smaller molecular what called like components, right? In a logical manner. That's number one. Number two, you use the elementary chemistry that you have studied at first year, second year, third year. So all that knowledge must come into feature here. Let's look at this example here. Here we say 1,3-dioxygenated. So in this case now, like I've got two functional groups. One, C double bond O, H, that's an aldehyde. That's my functional group, right? This is one, right? Now, 3 carbon atoms, 1, 2, 3. Then I've got an oxygen there. Hence now like I've got 1,3-dioxygenated. So that's a 1,3-dioxygenated what? Skeleton. So here, the very first carbon atom is referred to as an alpha carbon atom. This one is a beta, what call it carbon atom, gamma, etc., etc., etc. Right? Now, how do I disconnect this type of compounds, right? So this is how we do it here. So you go to the bond between your alpha carbon atom and your beta carbon atom. That's the carbon atom, right? Where you are going to disconnect, right? So in this fashion, right? When you have a beta hydroxy aldehyde, a beta hydroxy carbonyl compound. So this is what you do. Alright? Remember, you've got your oxygen carbon atom here. You've got, your oxygen here atom, your carbon atom here. Oxygen is much more electronegative than carbon. Therefore, it has the tendency of pulling the electron density towards what? Towards itself. So, leaving this carbon atom being what? Positive. Right? Now, the carbon at the alpha position, it's going to release electrons to this electrophilic carbon atom, right? So hence now like here, the type of movement, it's going to be from the double bond to oxygen, right? To create an electrophile here. So this electrophile here, it's going to take the bond between your alpha position and your beta position, then it comes over here to give you a double bond here, right? Then that's where you break. So this one, isn't it most like it's going to be positive? Then that positive charge, it takes away the bond pair between oxygen and hydrogen. Then that bond pair is used here, right, to generate a double bond here. So you end up with this type of aldehyde. You end up with an aldehyde, like in quotes, here. So you have broken that into this component and the other component, right? So then ended up with a double bond, single bond. So when those electrons come in, they give you a negative charge. Now, can you see now, if you look at this enolate here, right? So what happens is that now, it's your oxygen, single bond, double bond, so there's going to be conjugation. When these electrons are drawn in here, then these ones are forced to move out. So as a result now, this structure is resonance, stabilized. This ion is resonance stabilized to generate this ion here, this enolate in this case, right? So between the two. So automatically now, I see that here I will have an aldehyde, and here I've broken this into an aldehyde. Then an aldehyde and an aldehyde, it's an example of what? Of a reaction that we encountered at first year or second year level, which was referred to as the aldol condensation. So this is the aldol condensation in reverse now. You see? So that is very important. So with aldol condensations, in terms of synthesis, if you go back now like to your chemistry, with your chemistry now like at first year, what does it say about aldol condensation? Aldol condensation, you've got your aldehyde and another aldehyde, right? Two aldehydes, right? You treat them with a base, like if the reaction is going to take place under basic medium. So in this case now, like treated with OH minus, right? And then what will you get as a product? You will get a beta hydroxy aldehyde in this case, right? So this here is my retrosynthesis. This here is my synthesis. So here, these are my synthons that I'm going to use here, right? As I reassemble my what? My synthons under these conditions together. So this is synthesis. But if I'm moving from this side backwards, it is what? Retrosynthesis. That's what I've done in this step here, right? So there is my target molecule. Now, in the next what we call like lecture, then I will show you now like the mechanism. In fact, this one like you're supposed to have already what we call like learned it at first year or second year, depending, you know. But I'll do it for you, isn't it? I'll show you now like how this reaction actually takes place. Actually take place in terms of the mechanism, right? I'll see you in the next class. Thank you.